Good day, everyone. For today, we will be discussing about the database classifications. But before that, let us know first what database management system is. Database management system refers to a software package designed to define, manipulate, retrieve, and manage data in a database. Specifically, a proper database management system helps increase organizational accessibility to data, which is why it helps or it plays a vital role, an important role to any organizations like government organizations and even business organizations, as it helps the end users share the data quickly and effectively across the organization. Moreover, it helps get quick solution to database queries, thus making the data access faster and more accurate. It also serves as an interface between the database and end user to ensure the data is well organized and easily accessible. So some of the common example of this database management system or DBMS are the Oracle, IBM DB2 or Database 2, and Microsoft SQL Server. So database management system can be classified in many ways. One of its criteria is according to the number of users who can use the system concurrently, meaning at the same time. It can be divided into two, namely the single-user database system and the multi-user database system. So let us start with the single-user. Single-user from the word itself, at one time, only a single user can access the database. In other words, it can only support one user at a time. Hence, the user can use all the resources at all times, and these systems are used for personal usage. Moreover, single-user database does not have multi-programming. Thus, single CPU can only execute at most one process at a time. Example of this are the Microsoft Office Access, FileMaker Pro, which are designed to support single-user implementations. Another one is the Microsoft InfoPath, which is a software that is part of the Microsoft Office suite that helps people collect and organize information from a variety of sources. So, to understand it more, let us take a look of this diagram. Suppose that this is user A and this is user B. So if user A is still using or accessing the database, user B needs to wait until user A is through. Like what I have said earlier, since this is a single user database system, it can only cater or it can only support one user at a time. So in order for user B to access the database, he must wait for user A to be done or to be through accessing the database. This is figure 1, desktop or personal database. When we say desktop or personal database, these are the databases that run on individual computer like personal computers like what they are using here and can store a variety of smaller data sets. Next is the multi-user database system. It's a more powerful, expensive system that allows dozens or hundreds of people to access the same database system at the same time. So compared to the single-user database system, this is more powerful and it can cater dozens or hundreds of people access the same database system at the same time. It can also handle the most complex data processing tasks and are accessed over a network. And because it is accessed over a network, one database can serve many locations around the world. Example of this are the databases of banks, insurance agencies, stock exchanges, supermarkets, and etc. So to understand it more, here is an example here. The Lin Group is a global leader in industrial gases and hydrogen production. It has 50,000 employees, spread across 100 countries, all access a central database stored in a data center in Munich, Germany. So they have their database stored in a data center in Munich, Germany, and it's 50,000 employees spread across 100 countries and access the same database system at the same time. So that's how powerful the multi-user database system is. Despite they are in the different countries and there are so many of them, but then they can still access the same database at the same time. The next classification of database management system are the client-server database system and the end-tier database system. So let us start first with the client-server. In order to understand this, let us first discuss what is client and what is server. Client here, whether it is a machine or a program, it is an appliance and a way to make requests through the web. Server, on the other hand, runs server programs and provides functionality. It always listens for requests, and as soon as it receives one, it responds with a message. So to understand it further, let us take a look with this diagram here. So this diagram it shows the client-server model. So the client-server model is architecture on the web that splits computers into two sections. So this is one section here, and this is one section here. So this section are called clients since these are the computers that requests or that make requests to the server. And this section is called the servers since they are the one who give response to the request of the clients. The client-server database system, it has a request-response service provided over the internet or through an intranet. So as what we have observed on the diagram earlier, they have this request-response service. The client requests to a server, and then the server provides a response to the request of the client. A great example of this is the automated teller machine, or the ATM. A bank is the server for processing the application within the large customer databases. An ATM is the client having a user interface with some simple application processing. So in this example, the bank serves or it stands as the server and the ATM as the client. So the ATM requests to the bank, which is the server, and the bank provides a response to the ATM, which is the client. The next one is the n-tier database system. N-tier is also called multi-tier architecture. It refers to any application architecture with more than one tier. So it is usually divided into three tiers: the presentation tier, logic tier, and the data tier. It also helps to manage all the components: the business layer, the presentation layer, and the database layer of an application under one roof. So we have diagrams here, but let us discuss this one first. We have the presentation tier. The topmost level of the application is the user interface. The main function of the interface is to translate tasks and results to something the user can understand. So in here, the user wants to get the sales and its total. Next one is the logic tier. This layer coordinates the application, processes commands, makes logical decisions and evaluations, and performs calculations. It also moves and processes data between the two surrounding layers. So this is where the process happens. Get list of all sales made last year. Next one is the data tier. In here, it is where the information is stored and retrieved from a database or file system in here. The information is then passed back to logic tier. So we have now the sale 1, sale 2, sale 3, and sale 4. After that, we have to add all sales together and then eventually back to the user. This diagram here shows the presentation layer, business logic layer, data access layer. So in this diagram, in the presentation layer, it is where the user interact with an application. Second layer, which is the business logic layer, is where the presentation and the data communicate with each other. Last layer, which is the data access layer, it is the layer which is basically the server that stores an application data. So this is the database.
Good day, everyone. Now I'm going to discuss the centralized versus distributed database systems. First is, what is a centralized database system? A centralized database system is stored in a single location. For example, a mainframe computer, for instance. It can be accessed, maintained, and modified only from that location. So pag sa centralized database system daw, yung data na in-store natin is ma-access lamang sa isang mainframe computer. Doon lamang siya ma-open or magagamit. Uh, in a centralized database system, one computer act as a server o so yun nga for storing the whole data. Can be accessed using an internet connection using a LAN or WAN or local area network or wide area network. The centralized database system mostly used in, for examples, first is in schools, next in banks, and last is hospitals. So these are the uh, ones that mostly use a centralized database system. Kasi yun nga sa pag-iimbak ng data or pag-i-store nito, may isang server dito na mag-access o parang siya yung magmo-monitor. Next is advantages of centralized database system. Since there is only one database file, it is easier to get a complete view of data. Next is manage and update and backup data. Next is all data is stored together and not scattered across different locations. So yun nga, kasi silang naman yung server, so hindi ma-spread out yung mga data. Hindi ito madaling ma-copy ng iba. Next is the centralized database is cheaper than other types of databases as it requires less power and maintenance. So yun nga, since isa lang din yung server, less power and maintenance lamang yung mga gamit. Uh, and hindi kagaya ng iba na mas marami. Next is all the information in the centralized database can be easily accessed from the same location and at the same time. Next is disadvantages of centralized database system. First is since all the data is at one location, it takes more time to search and access it. If the network is slow, this process takes even more time. So yun nga yung isang disadvantages nito. Next is, since all the data is at the same location, if multiple users try to access it simultaneously, it creates a problem. So yun nga, pag sunod-sunod na yung mag-open ng isang data, mag-cause na ito ng problem. This may reduce the efficiency of the system. Next is, if there are no database recovery measures in place and the system failures occurs, or may problema nangyari, then all the data in the database will be destroyed. Um, Next is, there is a lot of data access traffic for decentralized database. This may create a bottleneck situation. So pag sinasabing bottleneck situation is parang dun, feel ko lang ha, parang dun siya it talks about the specs of a computer. So parang pag kung parang hindi na kakayanin ng computer mo yung data, Pag may nangyari na access trafficking or data access trafficking for sa isang centralized database, parang magka-crash ito. Next is centralized database system illustration. So, ganito ang kanyang illustration. So, ganito nga yung isang computer dito. Ito, number 2 and 3, nakakonect lamang siya sa isang mainframe server o mainframe computer. Same lang din dito. Next is, what is distributed database system? In a distributed database system, management system, the database is not stored at a single location. Di ba sa centralized database is nakastore siya sa isang single location lamang? So sa distributed naman ay hindi. Rather, it may be stored in multiple computers at the same place or geographically spread far away. This is also a integrated collection of databases that is physically distributed across sites in a computer network. Two types of distributed database system. First is the homogeneous. A homogeneous distributed database is a network of identical database stored on multiple sites. The sites have the same operating system, DDBMS or the Distributed Database Management System, and data structure, making them easily manageable. Homogeneous bases allow users to access data from each of the databases smoothly. So yun, yung nagagawa ng isang homogeneous na type ng isang distributed databases. The following diagram shows an example of homogeneous database. So ganito, yung parang tatlo yung core server at yung operating system. Pare-pareho lang sila ng operating system, data structure, and ito yung mga nag-access nito. Same goes sa finances, sales, and HQ or tawag na headquarters. Next is heterogeneous. Heterogeneous distributed database uses different schemas, operating systems, DDBMS, and different data models. A particular site can be completely unaware of other sites, causing uh, limited cooperation in the processing user requests. Ito yung kanyang illustration. Di ba parang sa sa homogeneous is nakakonect lamang ang tatlong operating system niya. Kapareho lamang, habang sa heterogeneous naman ay hindi. Parang uh, agad-agad ito nakaka-access sa main sariling server niya at hindi ito kumbaga pa hindi siya nakakaabala sa ibang server. May sarili silang server. Next is advantages of distributed database system. If there were a natural catastrophe such as fire or an earthquake, all the data would not be destroyed and it is stored at different locations. Yun nga. So it is cheaper to create a network of systems containing a part of the database. This database can also be easily increased or decreased. Next is, even in some of the data nodes go offline, the rest of the database can continue its normal function since iba-iba naman sila ng server. Uh, Disadvantages of distributed database system. First is ensuring data. Transparency and coordination across multiple sites often requires using expensive software in a distributed database system. So, di ba nga sa pagka centralized database system is less expensive, dito naman kay distributed is uh, it uses expensive software. So, since marami naman yung server na gamitin, mas malaki yung gagastusan. A possible issue when using database replication, oh, in is data integrity or originality, which is compromised by updating data at multiple sites. O since, for example, gagawa ako ng isang project, then yung aking kasama or ka-office mate is i-edit niya yung project rin na ginawa ko na pinagawa sa amin ng aming boss. So magiging mahirapan yung boss namin pag sa pag determine kung saan doon yung original na work na kanyang titingnan. Next is many operations on multiple sites requires numerous calculations and constant synchronization, causing a lot of processing overhead. So, since yung data na ginagawa namin is isa lamang yung, uh, for example, yung goal niya. So, since i-open ko yung, for example, gusto kong i-open yung data sa isang uh, computer server. So, mas mapapatagal yung pag-synchronize ng mga data sa iba't ibang server na aming ginagamit. Next is let's talk about disk-based versus in-memory database systems. What is disk-based database systems and in-memory database systems? Memory and disk storage both refer to internal storage space in a computer. Each is used for a different purpose. Disk-based database system. Devices that use magnetic hard disks for storage. It often refers to portable devices such as digital music players that have hard disk rather than flash memory. So, yung flash memory is yung mga gaya ng mas tinatawag natin ngayon na flash drive. Uh, all desktop and laptop computers are presumed to have hard disks, and most servers have hard disks. Accessing data from a disk is not as fast as accessing data from main memory, but these are much cheaper, and unlike RAM, random access memory, disks hold on to data even when the computer is turned off consequently. So kahit na for example example nito is for example yung laptop na gaya ng mga noong una pang mga model, di ba may na pwede pa itong lagyan ng mga disk. So, for example, yung biglang na-off yung computer natin or laptop sa habang nandun pa yung disk sa loob. So, hindi ito magkakos ng damage or okay lang. Disks have historically been the storage medium of choice for most types of data, but are slowly being replaced by newer forms of storage like flash drives. Yun nga. Next is solid state drives and cloud storage. So yung cloud storage yung in-explain nga ni Sir na yung parang new way ngayon ng pag-save ng mga file using internet. Next is types of disk. First is the magnetic disks. Magnetic disks is a storage device that uses magnetization process to write, rewrite, and access data. It is covered with a magnetic coating and stores data in the form of tracks, spots, and sectors. Uh, Magnetic disks come in number of different forms: floppy disk, hard disk, removable, cartridge. First is floppy disk. A typical 5-inch floppy disk can hold 360 gigabytes to or 1.2 megabytes. So 3-inch floppies normally store between 400 gigabytes and 1.44 MB of data. Floppy disks are obsolete today. Obsolete so means parang hindi na siya mas ginagamit talaga sa ngayon, but are still re- referenced in some modern iconography. So pag sinasabing iconography, yung parang yung sa cellphone natin yung mga icons. So parang yung isang disk is laman lang nun yung mga icon na ginagamit natin. For example, yung mga emoji. Mas kaya natin yung emoji. So sa iconography lang is black and white lamang siya. Wala siyang colors. Ganito yung mga example ng illustration ng floppy disk. Parang maliit lamang na ay memory card siya, di ba? Next is hard disk. Hard disks can store up to 20 terabyte of data. They are still used in modern computer systems, although solid-state drives or SSDs are more common. Ganito yung example ng hard disk. Next is removable cartridge. Removable cartridges are portable discs encased in a metal or plastic cartridge. Removable cartridges are fast, though usually not as fast as fixed hard disks introduced in 1960. So, makaluma na itong mga ganitong model. So, ganito yung itsura niya. Parang malaki siya, hindi siya flatten. Next type of this is the magnetic disk. So, optical disk. Optical disk, optical disk to, kamali lang Optical disk record data by burning microscopic holes sur- in the surface of a disk with a laser. To read the disk, another laser beam shines on the disk and detects the holes by changes in the reflection pattern. So ganito yung for example nito, yung sa CD is pag i-zoom in natin ito gamit yung mga microscope, for example ganyan, ito yung makikita natin na microscopic holes. Optical discs come in three basic form, CD-ROM or worm and erasable optical pala ito sa ano. Nga, no? First is CD-ROM. CD-ROM stands for Compact Disc Read-Only Memory. So most optical discs are read-only, meaning they are come pre-filled with data. So pag sinasabi yung CD-ROM, yun yung mga data na may laman na radio. Example nito, yung mga sa perya, yung binibili natin na CDs noong unang panahon na wala pang internet. Kung yun yung paraan na para maka-watch tayo ng movies, di ba? Users can read the data from a CD-ROM but they cannot modify, delete, or write new data. So yun nga, hindi siya, yung data sa loob nito is hindi pwedeng ma-delete or makapaglagay tayo ng bagong data. Ito yung illustration niya. Tinatawag natin ito madalas sa mga typical na tape lamang, di ba? Tape. Next is worm. Stands for write once, read many. Worm disks can be written once and then read numerous times. However, a special worm disk drive is needed to write data onto a worm disk. Ito yung illustration niya. Ayan. So parang may disk lang din siya pero nasa loob. Next is erasable optical. Erasable optical disks can be written to and erased just like magnetic disks. So ito yung illustration niya. Di ba kapag yung ito nga sa CD-ROM nga hindi pwede mag-delete or maglagay ng new data, sa erasable optical naman pwede. Erasable optical disc can be read to written to and erased just like magnetic disks. Next is in-memory database system. An in-memory database or IMDB or main memory database system is or mas tinatawag natin na RAM sa ngayon is a database management system that primarily relies on main memory for computer data storage. So dito sinesave yung mga data natin, for example sa laptop. Ito yung the drive. So it is contrasted with database management systems that employ a disk storage mechanism. So advantages of in-memory database system. Data is stored in main memory, so dramatically faster than disk-based databases. So since injected naman siya sa laptops natin or computer, so no need na no need na parang i-access siya physically gaya ng disk-based databases. So, good backup procedures are essential. Madaling makapag-backup gamit ito ng mga data. Requires fewer CPU instructions, and data can be more easily restored from the disks of a traditional databases. So, mas madali makapag-restore gamit ang in-memory database since nakasave lamang siya at pwede mo, for example, may na-delete ka na file or yun nga yung mas natawag natin na sa computer na yung recycle bin. Doon natin ma-restore ito. Yun yung paraan para ma-restore yung mga na-delete natin data. So yun lang. Ito yung these are the researchers of our part. Fir- First is kamali ito. First is Regil Manaongsong and no, sorry for this. Pala is si Miss Febri Malaza. Problem lang dito ha. Research. These are the researchers, Miss Febri Malaza. Next is me, Regil S. Manaongsong, and our advisor, Danver Palmiano. That's all. Thank you.